Hello everyone, this is Rashida. Welcome to my channel. Today we are going to work on a classification problem using Ada Boost algorithm in Python. In my last video, I showed you step by step how Ada Boost algorithm works, and I have the link in the description box below. Please feel free to watch it. It is always a good idea to know and to learn how the machine learning model actually works. We will move a bit fast today as we worked on several other machine learning models in previous videos in Python scikit-learn library, and they all pretty much follows the same format. Let's dive in. So here is our data set. Here we have all these different health parameters, different parameters that comes out from blood test, and we have this column disease. So in this problem, we are going to predict the disease based on all these other parameters we have. So here I'm checking for the null values in each column, and they're zeros, so no null values. And we have total these 5 different kinds of disease. Actually, first one is not disease, it says healthy. Either the person is healthy or the person has all of these 4 different kinds of disease. And in the dataset, we have total of 23 and 51 rows of data, 23, 51, 23, 51 samples. And as I mentioned, that the disease column is going to be a target variable. So from the whole data frame, if you drop the disease column, you get the X, the training features, and just capturing the disease column, you get your target variable. And using the train test split method available in scikit-learn library, we split the dataset into training and testing set. And for testing purpose, I'm keeping 20% of the data here. Let's get into the fun part, the model development from scikit-learn.ensemble import Ada Boost Classifier. Okay, now let's call the Ada Boost Classifier method. At first, I will just accept the default parameters and feed our training data in it, X train and Y train. So model development is done. So simple. Score. I will get the score from the test data. How about that? X test, Y test. So pretty pathetic, 42% accuracy. So the default parameters didn't do really well, right? Let's try some different parameters. CLF1, CLF1. Let's check what are the parameters we have available for Ada Boost Classifier. Here is the documentation. You can see these are the parameters, right? We have estimator, default is none. We will keep it as it is. Decision tree classifier it uses, and that's totally fine. If you watched my last video, I actually explained it how it uses decision tree classifier, right? So n estimators, so how many trees it usually builds. So the default is 50, the learning rate. If you don't understand how learning rate works, I have the link in the description box below. I explained in my gradient boosting method how learning rate works and what is the role of learning rate in this kind of ensemble machine learning model. Learning rate is very, very important parameter all through machine learning and deep learning. So you should learn how learning rate works and how it is used. And this is the algorithm. There are 2 options. So today we are going to play with n estimators and learning rate. N estimators. Let's see if we put 125 and learning rate 0.5. All right, let's run it. Wow, this time we have 96% accuracy. Impressive, right? Huge improvement. Let's try a complete different setup. Instead of 125, why don't we just 20? Okay. If you remember, an estimator 50 is the default. So first we tried much higher than default. Now let's try much lower than default. Okay, learning rate, here we used 0.5. Remember, learning rate default is 1. Okay, we tried it 0.5. Let's try it 0.05. CLF 2. Let's try the scores as well. 77%. Still much better than the default, right? So we're going to accept this one because this one got the better results. And I encourage you to try with different other parameters too. Look, my two N estimators, one was 20, one is 125, huge gap, right? Try something in between and see what happens. Learning rate as well, 0.05 and 0.5. Please feel free to try learning rate of 0.1, 0.3 or 0.03, something like that. I want to see how this performed on each category. We have five different categories. So let's see how on each category this CLF1 performed. So for that, we're going to predict the disease using this X, all the training features of all the data before the training test split, and use this CLF1 to predict the disease and add a column called predicted disease in the DF. So predicted disease CLF1 dot predict. I will pass this X. Okay. So it's just going to predict for the whole data frame. Let's see how it looks. If you go towards the end, you will see the predicted disease. We also need a column that will compare disease with predicted disease and tell us if the prediction is correct or not for each row. So let's do that. Accuracy. So df dot disease. We need to equate that with bf dot predicted disease. X is 0 dot as type int, so that we can perform some mathematical operations on that. Let's see the df dot head again. So I have this column accuracy. So when this disease and predicted disease matches, it shows 1. And if it doesn't match, it will show 0. So that's how we will know if the prediction is accurate or not. And now let's see df dot group by disease accuracy dot sum divided by df dot accuracy dot count. So that gives us the percentage or proportion of the accuracy on each category. So you can see that diabetes, healthy, and thromboc, these three category, we got 100% accuracy on the prediction. But in anemia, and I don't know how to pronounce this, thalassemia. So in anemia, we have 93%, and this category, thalassemia, we got 0.889, kind of 89%. The accuracy looks pretty high. And who knows, if you try with some different parameters, different N estimators and learning rate, you will probably get better accuracy. So please feel free to try it. And also, please feel free to try with this Ada Boost regressor as well. Take a data set and use this Ada Boost regressor model. And you can use the N estimators and learning rate, these two parameters as well. Also, in regressor, you can try with 3 different loss functions. Default is linear, which works pretty fine. And estimators and learning rate, you just can tweak these two. If you wish to, try with loss as well. Take a data set, and it's exactly the same working procedure. So I'm not going to make a different video on that. That will be all for this video. Please like, comment, share, and subscribe if you like this video. Thank you so much for watching.